I think I should go up on Fiverr and find somebody to make us a jingle for our live streams.
Hey,
there you go. Hey, Don.
I got a new bass, man.
There you go. Oh, there we go. All right. Welcome, everybody, to another episode of our Labs. Oh, let me try that again. I had YouTube unmuted. Welcome, everybody, to another episode of our Labs Open Office Hour. This week, we're joined by our scientific computing advisor and Santa Claus impersonator, Dr. Don Kinghorn. So I'm actually kind of excited. It's been a little while since we've had you on the show, Don, and you're always one of my favorites to talk to because it's always fascinating and interesting stuff. I like to do this every time, just in case anybody doesn't already know. Let's give a little intro and background in what you do and who you are and all that stuff.
Okay. I think the title is probably self-explanatory. Scientific Computing Advisor. PhD, theoretical chemistry, years ago, been a researcher, whatever, always a computer nerd. And at this point, it's like focus on helping my colleagues and playing with cool new hardware and stuff like that, which is always fun.
Right on. So I guess to start off, what's new for you and Don?
Well, aside from the really cool recipes that we were exchanging earlier before the stream started. Yeah. Oh man, 2021. Oh,
Yeah.
Yeah. This is. I have high hopes for it, but I expect a rocky start.
Sure.
So we'll see. My wife just got her second COVID vaccine.
Right on. Cool.
She's a nurse. And so in a couple of weeks, she should be good to go.
Nice.
Looking forward to that for myself and everyone.
Yeah, that'll be nice.
Yeah. Whew, boy, it'd be great. It's going to take a while before we can get all this behind us, but yeah, it should be good.
Which actually, that's an interesting kind of subject to bring up there, because I think in relation to a lot of what you kind of have your fingers into, I think part of the reason we as a collective were able to kind of knock this out as quick as we was because of the kind of scientific computing efforts. There was a lot of people were getting involved, the folding at home efforts and things like that. There were a lot of people, both like on the grassroots all the way up to heavy duty, like universities and stuff, all getting their fingers into figuring this out as quickly as possible. And that's huge. We made a huge impact.
Oh yeah. That was very satisfying. We had several, we had quite a few machines going out, specifically people doing molecular dynamics and stuff like that were investigating the SARS-CoV-19 and that was really nice. That's one of those things you feel good that you're contributing to that effort, and that's that big deal.
Mm-hmm.
And some brilliant work was done. Oh man, just huge. The vaccine. New techniques there.
Yeah,
really great stuff. This is going to be game changing for everything going forward. So it's
very cool.
It was like a moonshot.
Wow,
a lot of big, important technological advances were made.
Awesome.
So it's it's a little bit of a silver lining there. It really moved things forward. So so that's good. Yeah, it's kind of miraculous that it happened. Awesome. The research went off so quickly.
Yeah, that's good stuff. I know one topic you had mentioned in your tweet just before we went live was Intel now has a new CEO, an engineer, which is a bit of a departure from their usual tack, I think.
Yeah, it's been a while since. Yes. Intel. Okay. Yeah, I've actually got a lot to say about Intel. I'm actually I'm starting my year off doing something that I've wanted to do for quite some time, and with Intel One API, and I'll get to that.
Ooh, okay.
So I'm pretty much kind of focused in Intel camp right now. Um, but yeah, change of CEO. A lot of it's super interesting. I mean,
I'm excited. I think this
yeah,
will be really cool.
me too, because man, Intel needs some really good stuff happening. Yeah, and I mean, Bob Swan was great.
Mhm.
Really respect that guy, and I think everybody at Intel internally did too.
Yeah.
Um, and but I'll just say the CEO before that, no, I'm sorry, I don't want to talk, diss anybody, but
Sure.
I think he did bad for Intel, and Intel really lost its way. And
And
oh man, yeah, that was bad. That was a
yeah.
bad era. And I think Swan did uh, a good job with recovery from that, kind of like internal and just kind of getting everything back. And Gesslinger should be awesome. Hopefully, I'm pronouncing his name right. I'm known him for like bazillion years. I mean, at
Yeah.
least of him, right?
Sure. Sure.
But yeah, he's an engineer. He's a good guy. He's been a lot of places. He's been at Intel.
Hmm.
Um, um, I think really, really good thing. I think
Yeah.
this is going to be hugely positive for Intel.
Yeah, I think so too. I feel like as an engineer, it'll bring the focus back to the product, like what it is that they're what made them great to begin with was
Yeah,
that the fact that they had like innovative engineering and they were making new things. And when you're at the top of the heap, it tends that the marketing guys and the salespeople end up at the top, and that's kind of, you lose focus. It all becomes about trying to make a dollar and not trying to innovate. And I think we're going to see some good changes. It's going to take a while. They're a behemoth.
yeah,
It's a hard boat to steer. So, but
yeah. And
I think
Intel is huge. They lost a lot of good people a few years ago, which was really kind of a shame. Um, but there's good people again. There's a lot of interesting projects going on.
oh, for
Um,
sure.
it will be very interesting to see how the focus changes.
Hmm.
Hopefully, they'll collapse their product line a little bit and get it more like sensible.
Yeah.
Um, and I think, yeah, totally believe all that will happen. So I think it's really good. Um, I've been, I've been kind of puzzled by Intel for a while.
I
Over
think
the
I
years.
think a lot of folks have, like, why, and I don't, this is kind of a rhetorical question, but like 14 nanometer has been their thing for like 10 years or something. Like, it's been the same basic process for a long time. And you would think somebody or a company with the massive just capability, they're huge, they got billions and billions of dollars that they dump into R&D and stuff. What has kept them from making that jump? I don't.
Yeah, I mean, that that's that's hard. I mean, and it just it's surely just a big combination of things. First of all, the chip design itself is this big monolithic architecture
Mhm,
is a little bit tough to deal with, because if you have
mhm.
any flaws, you just trashed it.
Sure.
Um, that's
Yeah.
where AMD has really moved forward with that, with
So
the
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 chiplet thing, right?
chiplet, yeah, the clusters.
Mhm.
That's like, yeah, really, really smart. That was brilliant stuff. Um, and yeah, there's and just to do a fab that can
Mhm.
produce with good yield at that small feature size like that is like, whoa, yeah, that's tough. So yeah, that I'm sure that was just a big, a lot of things going on there.
Yeah.
but it looks like they're gonna, it's like facing reality, and it's like, okay, they're gonna have to bring in outside fabs. Hopefully they will refresh some of they really need to refresh some internal fabs. We need to have
Right.
a robust foundry in the US uh, state of the art chip. So, and I totally expect them to do that.
We do have a question from YouTube
Sure. Sure.
on this track from Brett. Actually, if you were the
Oh,
CEO of
nice.
Intel, what products would you focus on in your first year in the position? Where would you put resources, and where would you pull them?
Okay. They a couple things. They first of all, they just need to trim the line. They need to bring it, something sane, something on the consumer side that makes sense. And then on the high end side, they really should be focusing on Xeon and multi and single socket. Um, and they need to do some of the things that they have not done that they could have done. I mean, they could have done a PCIe 4 years ago.
That was an interesting, yeah.
Yeah.
That they, I remember, it was toward the end of toward the middle of last year. They put out an SSD, PCIe SSD, that was PCI Gen 4, but only AMD platform was supporting it. That seemed a very strange, just disconnected. It kind of showed that the different parts of the company weren't really talking to each other.
Oh, that's a big deal in Intel. I mean, I'm not there, right? But
Right.
it appears that there's a lot of islands, and there's a lot of groups that have a lot of clout that get a lot of push, and that was really bad in the past.
Mm.
That will probably change because
Right.
things are gonna have to pull their own weight. They're going to have to make sense.
Good.
But yeah, Intel's they held back on some of that stuff for multiple reasons. Part of it had to do with even with Microsoft. They were not changing things up to make a mess for some of their big partners.
Okay.
But yeah, they need to move it forward, and it's going to take a while. By the end of the year, they'll be back with a vengeance. They'll be back
Cool.
big time with their main core CPU products.
Awesome.
But so and that yeah, that's definitely what they need to do. They need to get rid of some of the cruft. They need to make some hard decisions about things like, they're going to hate me for saying this.
Optane.
I'm Optane. I'm looking at that right now. I mean, I'm kind of in that. I'm like, okay, yeah, there are some use cases. This is actually really cool when you need terabytes of system memory for staging big statistical analysis and stuff like that.
Okay.
Yeah, I mean, there is use case, but man, it's marginal and it's questionable. This is my opinion,
Sure.
and I think what they did is great, and I have tested it before. I've tested Optane, and I was like, hey, it works like they say. It's but it's really specialized, and it's to really exploit it. In general, you have to write code. I mean, you have to make changes, and
Okay.
mainstream apps are not going to do that. But using it as just a memory extension, persistent memory extension, it has some applications in like really big databases,
Oh, that's interesting.
stuff that needs to be in core, you know, um, really large data sets and stuff like that, which is more and more common.
Yeah. Oh, yeah.
So it has serious use case.
Hmm.
But I think it's not going to be viable going forward.
Ooh.
partly because of PCI, the advances in the communication of PCIe 4. Intel should have they should have PCIe 5 by the end of the year. They should have a
Yeah.
platform on the next spec. I mean, the spec's already out.
Yeah, that was fast.
Yeah, and they cannot mess around this time. They need to stay on top of stuff,
Yeah.
especially when they're partly responsible for it in the first place.
Mhm.
I mean, that's crazy. But that and with technologies like NVMe for storage, it's like, whoa, okay. There's just a small leap from extending core memory out to storage, and I think that's going to be solved. I was just looking at announcement of a new startup like yesterday. That's doing stuff on communication layer for memory, like distributed memory,
Mm.
consolidated memory spaces, whatever, over like clusters and stuff like that.
Ooh.
And with all communication over NVMe.
Wow.
So I think there's technology that's going to move forward that's going to like completely eliminate the need for what they were doing with Optane. Now,
Well,
so they may make a pivot there and do something more on those lines, which they totally could do.
mhm.
Um, but or they could just double down on it again.
Sure.
As time goes on, there becomes more use cases for it because data sets just get bigger and bigger and bigger, and you hit these problems.
Right.
The thing is, these problems are historic, so they've been dealt with in the past.
Oh.
So
Hmm.
it's
Mm.
having memory being a limited commodity available for the CPU has been around for a long time. So people have kind of worked around that problem. But
Yeah.
that's one that would be one that wouldn't be surprised to see it go away, and especially. Yeah, it's not the panacea that they're marketing. You get so tired of hearing it, it just becomes a
Well,
joke.
and it seemed and this is, I won't talk specifics because it's kind of internal talk that we've had at the company, but it does seem that even from what I've seen as a consumer, they marketed it to the wrong people. Like gamers or like the general consumer wasn't really shouldn't not have
Yeah,
been the focus.
and
It
then
seems
it's like, how many products does Optane actually refer to,
yeah. Oh,
right?
there's that too. Sure. Sure.
Like, yeah, there was like, well, what are you even talking about? What is this? Is this or is it this or yeah,
That weird disconnect
yeah,
again.
that was a disconnect. Yeah. But interesting that the thing that really was kind of interesting to me, just and especially with this CEO change just now, I've been wondering like what in the heck is Intel doing? They bought oh my God, it's been so long I can't remember their name. The FPGA company that they bought years ago.
Oh, it sounds familiar. I don't recall the name, but
Oh, for crying out
the
loud! Yeah,
event sounds familiar. Yeah.
but um, oh, it'll come to me or somebody will spew it out. But they haven't really done much there. I mean, they have, but it's like, okay, there's more stuff going on under the hood now,
Mhm.
and I'll have something to say about that. But there's that, and that's always a little bit questionable. It's like, well, why, why did you do that?
Sure.
And then they bought Habana, the
Mhm.
AI chip company,
Mhm.
which looks like really, really, really promising designs,
Okay.
and it's been crickets.
Hmm.
It's like, whoa, what's going on there? And then, um, so and another thing, yeah, I expected them to have, and they're working on their discrete GPU.
Yeah, that'll be interesting.
Now that would be
That's
interesting.
personally exciting for me. Yeah, I'm curious to see if that's something that they put a lot of effort into, or if that becomes a side project, or
I don't know how they're going to do this. I don't know what they're going to do.
oh,
It's
was
going to
it?
be really interesting to see. That what they desperately want what
Mhm.
is to be competitive in the accelerator market in a
Oh,
really, really big, meaningful way. And
okay.
so, so the moving the GPU forward into higher performance discrete GPU, that has ramifications across everything that they do, right? On
Sure.
from gaming on out.
Yeah.
But it also is, really could be really significant on the high-end compute side.
Sure. So
Um,
could we see like a better Phi card kind of a deal, or would it be more of a direct competition with AMD and NVIDIA?
it's probably going to be more of a direct competition with AMD and NVIDIA. Yeah, I mean
That'll be kind of cool.
that's what they
Output.
need
Like,
to target, and man, that's going to be rough.
well,
I
yeah.
wish them luck, but um, but hey, they can pull some rabbits out of their hat,
Mhm.
They've got really good people. One thing that was surprised me, and this I just kind of thought about this after the announcements of the changes and
Mhm.
stuff that we've heard today and everything. Um, Jim Keller, okay, the chip designer that was at AMD for a long time, who designed Zen.
Mm.
Right? I mean, he's an industry heavyweight,
Okay. Nice.
and
Wow.
he's been at Intel. Intel uh, lured some people away from AMD,
Mhm.
right?
Mhm.
I mean, there was some controversy about that. Intel was getting these people on board. Keller left like a little over a week ago,
Oh,
and he left Intel, and it's like, and I don't know what he was really even what what he was doing there, but I'm thinking that the changes going on over there right now and his departure are probably not coincidental. Maybe they are.
okay.
Maybe they are.
Okay.
But
Like,
he's gone on to CTO of a really interesting looking startup, and basically T- TensorRest or something like that, I think is the
mhm.
name of it.
Okay.
Um, that
Like he finished his mission for Intel and is off on
I
something.
don't know that his mission got the kind of internal support that he was hoping for.
Oh,
Who knows?
well, yeah, right.
Yeah,
It's all
I'm like,
black box stuff.
whoa, I could be way, way off. So I should probably shut up about that because I don't know.
Suddenly, Don
Um,
disappears. He's
yeah,
some
yeah. The
Intel
thing is,
goons
but
show up.
kind of ties in. It's like, well, where's Intel? Where's this stuff? They've acquired this technology and they've got these great people. What's going on?
Sure.
And so that was just kind of a question for me because I don't know. And I really think that over the next year we're going to see some really cool, significant accelerator designs,
Cool.
especially for machine learning stuff. Big matrix chips, um, tensor operation chips that are really focused and high performance. So
Yeah.
that's going to be tough because it's got to be usable. Um, but I've expected Intel to already have something like that, and they have it's not really
Yeah.
there. And they had
Yeah.
some stuff they did with Nirvana or whatever that I think that's right,
Right.
but that was kind of on the low end,
Yeah.
and not
I-
yeah. So they've had several things that just didn't really move them forward, kind of surprisingly. So I don't know what they're doing, but they do need to refocus their core and
mhm.
recover. I think they will do that. Um, AMD is rolling,
Oh man.
and
Um,
um,
good for
yeah,
them. So
this
stoked.
AMD stuff is looking really, really good. So, and I'm super, super, super looking forward to Threadripper Pro.
Oh yeah.
Um, and I think we can even talk about it a little bit because stuff has been
A little. I didn't. I
some
admit it.
some stuff is still NDA. There's an embargo, but the
Right.
design and I think even benchmarks are can be published now.
Okay.
Um,
I admit I didn't read all the way through the embargo
oh,
document.
you should read those. I read it very carefully.
Sorry, John.
But I haven't tested, so I have nothing to say.
Sure.
Other than I'm really looking forward to it.
Mhm. Mhm.
Um, they've got an uphill battle, but they've got some, oh man, the supercomputer going in what's the name of it? El Capitan, I think is the name of it.
That sounds like an Apple OS release.
Yeah, it's something. I think that's right at Oak Ridge. That's going to be all AMD. Okay, so that's going to be Epic and AMD GPUs for accelerators.
Oh, yeah. It says AMD
Okay, so,
powering the exascale era with El Capitan. Yeah.
yes,
To enable greater than 2 exaflops of double precision processing power, the U.S. Department of Energy, Lawrence Livermore National Laboratory, and so on. So that's just the headline. But wow.
Yeah, now that is going to be a game changer for AMD on the high end, because that's going to be very, very, very important machine for the US, which means that the community will have to come out to make that architecture more usable, more robust, well optimized for performance. That is, and I think that that has to happen.
Right.
So, and that's a thing that's been holding AMD back a little bit, is they don't have the resources like Intel does for compiler development and library development and all that kind of ecosystem-ish stuff.
Okay.
So they've been hamstrung a little bit, and Intel has had advantage on them. Because Intel's had fantastic compilers for ages.
Yeah.
And that's part of why Intel kind of won the battle back in the day, right?
Okay.
Back in the early days of cluster, it was Optane. It was AMD.
Oh, yeah.
And that stuff was fantastic. But even then, Intel compiler came out and it was like really good. Even on Optane, that got taken care of. They put it into that more than one time, like even recently, right? We won't go there. But it wasn't until Intel came out with Nehalem, they were like, that was a wake up call. And was going, oh, they're kind of in the same situation.
Oh, okay.
Right now. But Intel came out with Nehalem, and all of a sudden it was a better chip, and it was when the supercomputing Linux cluster thing was like really, really exploding, and it was enough better that people moved to the architecture, and then they had the infrastructure underneath that with the compilers and stuff like that. So performance was good, and it just rolled, and they just like AMD disappeared off the planet for a while. But that's changing. AMD's back with a vengeance, and Intel has been complacent, and NVIDIA has just smashed everyone for performance. And so it's like, wow, things really, really changed. But so I expect AMD to do well because of that exascale machine. That's very important machine. So there'll be more hands contributing to the performance effort for hardware. So
awesome.
That's a good thing. Going back on the Intel side, you can interrupt me at any time if there's like really cool questions or anything like that.
And
on the end,
the audience, be sure to ask. Like, that's why we're here.
Yeah. I'm just kind of winging it today. I'm not like doing any demos or sticking my neck out on stuff, but I'll tell you what I'm actually am working on right now.
Sure.
And this is, like I said, I'm this first part of this year, I'm doing a focus on some Intel stuff that I've wanted to look at for a while, and in particular, Intel has an effort for like really developing their developer ecosystem. They've always had one, but it's been like commercial. You have to buy licenses for the compilers. They've got these great tools, but you got to pay some money for it. And it's just been not well organized.
Yeah.
NVIDIA came in and just showed everybody in the industry how to develop an ecosystem. NVIDIA's CUDA ecosystem was just brilliant, and I every time I get an opportunity to give them kudos for it, I do.
Oh
because
yeah.
it would just change the world.
Yeah. And I've heard that a lot. Like that's the reason why CUDA seems to be like in everything is because NVIDIA put so much effort into making it easy to use. In fact, you've said that yourself is like OpenCL works just as well, but it's just such a pain in the butt to do anything with it. So
Yeah,
like everybody just uses CUDA because it's easier.
and yeah, for multiple reasons, not just because it's easier, but
Uh,
but
well,
they
the
nailed
support, I
the
suppose.
ecosystem, and I
Yeah.
mean, they made it. They really supported developers in the early days, and yeah, they pulled all the stops out and just really nailed it. And they did a brilliant job. They're still doing a brilliant job, and Intel still needs to learn from them.
So
But
I'm
I
gonna
can rant.
swoop in here. We do have a question from YouTube. Leonard Dog 27 asks, "What is machine learning with GPipe or GPU manifold? How many GPUs has I think how many GPUs does a system have to be called manifold?" I think I'm rephrasing the question a little, but
Okay, that's interesting. I'm not even sure what I'm sorry, but I'm really not even sure what you're referring to there by a manifold. Um, but I mean, I understand what a manifold is,
sure.
but
Well,
um,
I'm coming from a car experience, so I have not sure how this applies. So personally, that's just me.
kind of some analogies there.
Oh, interesting. Okay.
But um,
And then
yeah, just
he
kind of to answer your question, though. I mean, with multiple GPUs, the one of the main things that you're limited by there, at least on a workstation, is just power and cooling. You have to be able to power the things. Um, uh, Parallel performance on for multi GPU is well understood. Um, as far as like really having a cohesive, really cohesive architecture there, it's not quite there. Most of the stuff multi GPU is in the realm of distributed processing.
mhm.
Okay. So you slice things up and you send it out to multiple GPUs, multiple GPUs on multiple nodes on a whole cluster, right? Um, but so it's more of the kind of the viewpoint of MPI kind of application programming. Um, but I didn't really answer your question, but hopefully I said something
He
reasonable.
did he did follow up and ask what Puget system what I'm going to rephrase this question again. I apologize, Leonard Dog, but what can Puget Systems recommend for machine learning beginners?
Oh man. Okay. If you're a beginner, okay. First of all, I do recommend you can use things like um, you can like log into Google Colab and play with some of the notebooks and stuff in there. And Microsoft has some stuff, free resources on Azure. You can get in there and play with some notebooks and mess around with that. But I highly recommend. Of course, I'm going to recommend this. I'm a hardware junkie, right? But I mean, I would recommend this personally. For if you want to do AI machine learning work, you want to get into that, your gaming rig is going to be killer. Okay, as long as you've got an NVIDIA GPU in there. If you want to, you want to work, you want to use GPU, and you probably want to do that early. You probably really want to get used to doing things and utilizing a GPU for compute.
Mhm.
Um, but man, you can do this on any pretty much any gaming rig with any recent reasonably high end NVIDIA GPU, and it will be staggering what you can actually do. On the product side, from Puget, we're focusing uh, on more heavyweight, so more expensive machines, and
Yeah.
high end GPUs are expensive,
Right.
and so for us that means like the 3080 is a fantastic GPU. The 3090 amazingly good. I've run quad 3090. It's just staggering. Okay, but man, it's sucking. That was where I did this thing where doing power limiting on the GPU in order to get them within a reasonable power thing to run on a single circuit, right?
Which is still mind blowing, even limiting them to, I think, what did you end up finding the curve for that was like around 95% performance?
Oh yeah, I had better than 95% at like 280 watts.
Yeah,
down from 350. So it was like, whoa, yeah, okay,
that's great,
and the performance was like really good.
I love it.
But to answer your question though, pretty much, any kind of recent GPU. I will caution you a little bit on the RTX 30s.
Mm-hmm.
Okay, the dust is still settling on that stuff, and I've had testing difficulties, and for like there's several different chips there,
Mm-hmm.
and
That's right.
the 3080 and the 3090 are very good, and they seem to be working correctly.
Okay.
Drivers are working correctly. Stuff is working correctly. This stuff is happening. I have to get back in, because things are being updated like crazy. But there was a little bit of, like a lot of stuff on the software side wasn't quite ready for this,
Mm-hmm.
at least for this kind of application. I have not been able to get good performance out of a 3070.
Right.
I have not been able to get FP16 performance out of that, and I suspect the same thing would be true with the newer ones like the 3060s. So these lower end current GPUs,
Mm-hmm.
a little bit questionable. But if you've got something, the 2000 series, like a 2070, those are fantastic. So if you've got anything from a 2070 up on the 2000 line, those are great, and everything is going to work.
Okay.
Those are really well established. 2080 Ti was a workhorse. There's just bazillions of them out there. People have done magnificent work with those things. And if you can score one with as a good deal, then that's like a really great machine learning GPU. But right now, if I was going to recommend GPUs for that kind of work on your own local machine, I would probably say, yeah, it will probably get support on the 3070 and below will probably mature and everything will be fine. But I would probably caution be thinking like 3080 up.
So he does go on to mention that Colab has a time use limitations. He was curious about he needs his own hardware that allows him to run longer time machine learning processes.
Yeah, you want to own your hardware. I mean, that's it in the scheme of things. It's not that expensive, especially if you can justify this by like, this is a great gaming rig too.
Which, I mean, why not?
Yeah, absolutely, totally. And you can run, you can use Windows. I highly recommend Linux, but I understand the barriers to entry on that. But you can get a lot of work done, and you can do some serious stuff from the Windows side on your machine without having to do dual boot and anything like that.
What WSL2 is still coming, right? That hasn't been it's not an official release yet, I think.
No, WSL2 is out, but the GPU support in it is still not in mainstream.
Okay.
And that's a little bit iffy.
Okay.
Yeah, that's really, really hard, and I don't know if they're going to nail that down or not. It's hard to say. I haven't looked at it here for a month or so. I'm still running on Windows Insider, so I'm on Windows Next right now. But I haven't revisited that stuff. But still, I would probably on the Windows side try to go just with native. You can get TensorFlow working and stuff like that, and you can do some. You can do some serious work. You can do some interesting stuff. In the long haul, yeah, you're going to be using Linux at some point down the road. But don't let that be a barrier for getting in there and trying some stuff and doing some meaty calculations. Really try some cool stuff. Fire up style GAN or something like that. Really dig into the stuff.
Some of that is really good.
Yeah, you can totally do it. Yeah, that's good. That's great. But yeah, on our side, we're focusing. I've got a machine. I haven't. That's had it up and running for like a couple weeks. I took a couple weeks off, right? Exactly when we got the stuff, right?
Yeah.
But I've got a machine. Got a machine down at the office running right now, and I'm logged into it on my Linux box. That's running. That's got four A400s in it, or A100s in it.
Ooh.
The Tesla, the compute card. Those are monsters. There's so much capability there. I'll have a lot to say about that. They're expensive. That's the high end, really, really, really serious compute card. The what used to be called Quadro, the A6000s, they're rearing their head.
Yeah.
So, and that's probably going to be a fantastic machine learning card.
Cool.
Especially for multi GPU. And there's others. Another what was it? A4 or no A6 or something like that. There's another smaller card. Anyway, there's really cool, good stuff coming down there. On the workstation side, though, yeah, a couple 3080, or a couple 3080s or 3090s. And that's going to be a killer workstation, and we're doing a lot of those.
Yeah,
that's a big system for us.
So we have a question from Twitch. Deddy asks, "What does Dr. Kinghorn think about Raspberry Pi clusters?" And then he mentions that my mic was a little loud.
I love them. Oh man. Okay.
So tough.
We sent a machine. We're working with some wonderful researchers at Syracuse.
Oh.
That have a cluster of Raspberry Pis that are connected to microscopes that they created. That they remember that stuff is this is fantastic. And so we did machines for them to act as the main controller for this stuff. And what they do is they're looking at essentially like slime molds growing. They're looking at these swarming microorganisms and how they like self-organize and stuff like that. So they're growing stuff on the stages and petri dishes with these cameras mounted that are they're microscopes that are everything's run by Raspberry Pis. And brilliant application. After talking with those guys, I'm going, oh man, Caroline, I think I want to buy like 8 Raspberry Pi 4s. It's like
cheap.
I haven't done it. I'm chomping at the bit to do another Raspberry Pi cluster.
Mm-hmm.
And if you want an exercise in understanding cluster computing, parallel processing, and all that, man, yeah, get yourself like 2 or 4 the new Raspberry Pis. You will learn a lot. That's great. You can cluster those things and run MPI jobs and all that. I mean, it's really, really cool. Love them. I love that stuff.
And then there's another question from YouTube, and this one's a little more just generalized. Bass MQ asks, can you talk about the 3070 and 3080 power supply need with a 5800X? Some people are saying 750 watts is enough for the 3070. Some people are saying that it needs 850 watts minimum.
Okay. When it comes to power supply, err on the big side.
I agree.
Okay. First of all, the bigger power supplies are generally just better quality, and yeah, you don't want to skimp on that.
Let me see.
If you're doing it like a single GPU, okay, you're looking at 300 watts. Yeah, I don't, I don't have a specific recommendation, but I would just say, yeah, err on the side of the bigger, better power supply. So given that choice, I would go with the 850. I haven't used anything in any machine, I don't think, under a kilowatt power supply for ages. I mean, it's just like, yeah, I'm going to get a power supply. I'm going to get a big, nice power supply. Because, who knows what I'm going to hook up into that thing.
I can tell you by default, so this is with a 5900X Puget Systems by default, and you can't change this option, is an 850 watt power supply with a 3070. So you could probably get away with a 750, but you're safer with an 8.
No, you're pinching pennies there.
You're right. Yeah,
it's not worth it. Get a better power supply. I think that's why I was saying part of the reason, I'm pretty certain that we've had really, really good luck with our 850s.
Oh yeah.
So yeah, are those the new ones, or like the EVGAs?
The Superflower LEDX.
Flowers. Okay. Yeah, they're probably pretty much the same thing as the EVGAs and stuff.
I do think EVGA goes through Superflower for their power supplies.
So those
we just took another step up the chain.
Yeah, anything that we use, there's a reason for it.
Mm-hmm.
Okay.
I mean, yeah, it comes down to quality, really.
Yeah.
Just to go off on a bit of a tangent, our parts failure rates are incredibly low, like single digits and lower. So we try really, really hard to not have broken parts.
Yeah.
Either in-house or in the field. So.
Yeah, and that's something you don't want to skimp on. Don't skimp on your power supply.
And that goes for anything. Do not buy cheap $40 cheese ball funky no-name power supplies. You're going to fry everything else. Yeah. Buy quality power supply. Everything else, sure. And no, just don't buy nice or buy twice, right?
Yeah. I like that, man. That's
what it all comes down to.
Often true, but yeah, power supply is very, very important. Yeah, you need stable current for everything.
Yeah.
Yeah, nice. I'm glad we're getting some questions there. I hope getting good answers on you.
Mm-hmm.
If anybody wants to hear a little rant, I wrote down on my little yellow pad a rant.
Yeah.
I didn't get a chance to rant about it when it first happened. First of all, sorry for the spilling my water off my shirt. I'm going to drink.
You need a bigger beard so you can just cover it up.
Oh yeah, I should let it go. I should let it grow, man. I didn't get to rant about it in public earlier, although I was encouraged to do so. Matt was going, "Oh, Don should just go on the stream today and rant about CentOS."
Oh, that's right. That was a little while back.
Yeah. In the Linux world, CentOS, that's the community enterprise operating system.
Okay.
And it has been the foundation of that's what it stands for.
Yeah.
It has been the foundation for loads of infrastructure and clusters for a long time.
Mm-hmm.
Okay. It is based on the Red Hat RHEL, the Red Hat Enterprise Linux.
Okay.
And it's open source. So those packages are available in source code. The CentOS project was taking those all those packages, removing the Red Hat branding, recompiling them, and putting this into the OS distribution.
Okay.
So that was enterprise Linux. And it's been default. I mean, it's been a standard on for infrastructure for a long time. And there's a lot of people that's what stuff is dependent on.
Mm-hmm.
There's probably the majority of stuff out right now is probably still on version 7.
Okay.
But and it's still going to be supported out, I believe, through its whole life cycle.
Okay.
which is really long for enterprise Linux. Major versions of RHEL or CentOS have like 10-year support cycles. I
Oh
mean,
wow.
really, really long.
Yeah.
And but what just happened here before Christmas? Merry Christmas.
Oh.
Version 8, which has been out for a while, people were migrating over to it,
Mhm.
okay, and doing new setups and stuff on version 8. And with the expectation that, okay, this is another enterprise Linux. This is going to be supported as it is with its application binary interface, everything you need for a stable machine for
Mhm.
extended period of time. Fully expecting this is going to be supported all the way out. Okay, IBM bought Red Hat, or Red Hat bought IBM, however you want to look at it. IBM bought Red Hat.
Yeah.
But it's like where everybody's kind of going, ooh, is that good or bad? IBM's contributed massively to Linux. Okay,
Okay.
so I'm not I don't want to slam either any of these guys because they're fantastic members of the community.
Mhm.
But whatever, they like kind of out of the blue pulled the plug, and they said that CentOS 8 is not going to be supported for it. It's going to have a shorter lifetime for its support. And they're migrating. Okay, a few years back, Red Hat actually took ownership of CentOS.
Okay.
CentOS was a separate entity. It had nothing to do with Red Hat.
Okay.
Okay. But Red Hat went ahead and took it over. And the way that Red Hat works is they have Fedora Linux,
Mhm.
which is their testing platform. And Fedora is pretty cool,
Mhm.
but man, it's bleeding edge. That's where they experiment with stuff, and they do a lot of testing and experimentation in there. Stuff that really, really looks good that they want to keep, that's really stable, and they want to develop it forward. That eventually winds up in Red Hat Linux.
Okay.
Uh, but now what they want to do is they want to take CentOS, now that they've got it, and they are turning this into a rolling distribution. They're calling it
Mm.
Stream, I think. And that means it's not stable. It will never be stable because
Oh.
it's not a stable release. It's not a fixed. When you got version 7 or version 8, whatever, you got a kernel that didn't change. The Linux kernel, it would get patched like hundreds and hundreds of times, but it would
Okay.
not change. So that binary interface was solid. And that's what
Oh,
people depended on.
yeah.
But I don't know what they're going to do, but doing a rolling release with this stream, that means that stability, that the reason that people used it in the first place just got thrown out the window. So
Did
the community is not happy about it.
yeah, it's like, did Red Hat just become Windows 10?
I don't know what they did here. I don't, they had to have understood the backlash they would have from the community. They want to force people that are like dependent on that to pay the money for Red Hat, for
Hmm.
enterprise. So this is a slap in the face to the open community,
Yeah, that seems rude.
especially the cluster community. And I mean, I go way back with this stuff, so it's just like, man, it was disturbing.
So with the way Linux works and CentOS in particular, could somebody take like version 7 and run with that on their, and now it becomes, you know,
They
biscuits or something? I don't know, whatever they
Yeah,
would call
they can take the current 8 and run with it. And okay, CentOS was not the only distribution
it. Mhm.
that did this. There was Scientific Linux for a long time, CERN,
Oh,
right?
yeah,
Um, the accelerator
yeah.
place, right? They had their own Linux.
Cool.
They did this in house, and they did it the same way. And that was Scientific Linux. There was, I can't remember. There was a couple others too, um, but they dropped it. CERN stopped doing it a few years ago, and just they changed everything over to CentOS,
Mhm.
and just because of the resources they need to maintain a distribution. I mean, it's a fair amount of work. You have to have several people that are dedicated to it. And there's already, I can't even remember what it's being called. I guarantee anybody that's on CentOS right now and they're worried about it, don't worry, because things are not going to change for the rest of the year. And by the end of this year, I can pretty much promise you there will be a viable alternative.
Oh.
And Amazon Linux, or Oracle Linux, they're all based on this too.
Okay.
So this is open source, and they can't really pull the plug on that. Okay, right. So this stuff will happen. There'll be another community supported, robust, stable OS, that's based on RPM package manager and that whole ecosystem. So I'm not too concerned about it, but it was just kind of a slap in the face. It was kind of a surprise, and it was like, oh, really? Why did you do that? It was like spitting in the face to the community. It was right. It was not received well by anyone that I know of. Everybody there were people that ran it a lot more than me, because I haven't actually used it for quite a while. I'm pretty much exclusively on Ubuntu now.
Okay.
Although they drive me crazy sometimes, and if I was doing a big cluster or something like that, I would really be sticking my neck out to do that. But it's an opportunity for them.
Sure.
They can step in and support the community with commitments to stability and stuff like that. And why not? Younger folks coming up, they've grown up on Ubuntu, and sure. So it's become really quite the standard for a lot of stuff in the machine learning community. Pretty much everybody's running on Ubuntu. When you move into DevOps, on that higher end stuff, a lot of that stuff is running on enterprise Linux architecture under the hood.
Okay.
But so there'll be some changes there, but that's good. Anyway, I wanted to get that rant out in public because if you would have caught me like a few weeks ago, it's like, yeah, you could have got probably a lot more drama.
Sure. Well, it just seems like it's like another one of these stories of a big company coming in and kind of ruining it for the little guys, kind of.
Yeah, and it's puzzling because they're both really good companies.
Yeah.
That's the thing. It was disheartening. It was disheartening.
Yeah.
A lot of people really were kind of worried when Red Hat pulled in, basically kind of took over CentOS. People were kind of worried then, and they were right.
Yeah. It's a shame.
Yeah, but it's okay. Everything will be right with the world.
Yeah. Which
it's a really strong community, so it's not, and IBM and Red Hat, their stuff is really, really, really good, and there's really strong arguments for paying for the licensing and the support from those guys, and a lot of people do. I mean, a lot of people, and with good reason. So no, I'm not. That's fine.
Sure,
that's fine. But yeah, that was a real rant-worthy announcement when that came out.
Yeah. We have just a couple minutes left. I'm curious. ARM. So I know ARM is a big thing in high performance computing, scientific computing, and things like that. I think the number one supercomputer is running ARM right now. How do you think that? So we're hearing pretty good things coming from Apple and their ARM chip, the M series of chips. I'm curious how, especially with Apple getting in and NVIDIA trying to buy ARM and Apple with their chip and supercomputing at the higher level, how do you think all of this is going to affect more, I suppose, modest applications? Like I guess that's
Okay. I've been expecting ARM to kind of take over for several years now.
Mm-hmm.
It hasn't really happened as quickly as I thought that it was going to a few years back.
Mm-hmm.
What was the that big new acquisition with the man, I get on these streams and I forget. Nuva.
Mm-hmm.
Sorry.
No.
Oh man.
That's all right.
Nuvia. Okay, I'm sorry. Man, aren't they? Anybody can tell me anything? They just got bought. Qualcomm. Yeah, for crying out loud, man. I'm sorry. Qualcomm. Okay, Qualcomm, Snapdragon, right?
Oh, sure. Yeah.
Qualcomm bought Nuvia. Nuvia was a startup. Their goal was to basically unseat Intel and AMD. Okay, so this is higher end ARM stuff. Qualcomm had their own, the Dragonfly chips from a while back, and I thought they were gonna run with that and really go, and they pulled back, and I was like, whoa,
Yeah.
But yeah, so expect to see more ARM on the high. It's going to get really, really, really interesting. There's compelling reasons to go with ARM. There's a reason Apple's doing it. There's a reason that Microsoft is interested in it. Sure. And ARM is completely capable of as high end of computing as you want.
Mm-hmm.
So it's just a matter, and it's well established. I mean,
yeah, I think folks don't. I mean, in a general sense, like your laptops or not laptops, but like your phone, your tablet, those sort of things. I mean, the ARM chips are in a lot of stuff, probably more than we really realize.
Yeah. Oh, yeah. Because there's really, really teeny little things, right?
Yeah.
But that scales out. That scales up to, and that's the thing. You can design your own stuff around ARM. It's a licensed technology. But yeah, the big Fujitsu supercomputer is their ARM chips are big, massive honkers. Yeah, you can go as high end as you want with that stuff. And man, NVIDIA is not trying to get them for no reason. You know what I mean?
For sure.
And in fact, NVIDIA's been heavily vested in ARM for quite some time.
Mm-hmm.
And I had completely expected them to do a high-end ARM processor a few years back.
Oh,
where the processor and the GPU were more integrated, and they could essentially eliminate like Intel and AMD under the hood.
I think they kind of started down that path with the Shield, right? The Tegra and whatnot.
Yeah, they've had that for quite some time. But there was a project going on, Project Denver. They were going to do. It looked like they were going to do this in a big way, as a platform for the GPU acceleration. Okay, so for the heavy end stuff. So they're now looking at acquisition. That's going to be really tough for them to get all of the approval. It's going to take the entire year for this to happen.
Yeah, I think the hang up there is going to be the EU. I think they've already got the thumbs up from the United States. It's going to be Europe that's going to be, I think, because
it's controversial.
Yeah, Europe's a lot stricter when it comes to their antitrust stuff. They look really, really hard at that stuff.
And it's good, because if you look at this at a global perspective, is NVIDIA acquiring ARM really good for everybody?
Right.
I'm not sure. I think probably is. I have more trust in NVIDIA than maybe I should. But no, I have faith in NVIDIA to do the right thing. I mean, I say that sincerely.
Yeah.
And there's alternatives.
Oh,
Okay, there's RISC-V.
okay.
Another RARM is a RISC architecture.
Mhm.
Okay, that's reduced instruction set. This is what the old Unix processors were based on.
Okay.
They were RISC architecture, and there's huge advantages to that. It's way different than what Intel and AMD do. Okay,
Right.
I won't. Maybe I shouldn't say way different, but it's a different idea.
Right.
You keep all the instructions the same length, and then you use more instructions. Where like Intel chips they're big complicated instructions. They have various lengths and stuff like that. But you can make a very power efficient and robust and high performance architecture this way. But ARM is not the only game. Okay, I mean those processors, Hewlett Packard, IBM, digital equipment, they all had HP. They all had, they all had their processors, and the RISC-V. There's a new open hardware specification for RISC-V, and it's open source. It's open hardware, so it's not licensed. It's free.
Okay.
And Western Digital is already using a RISC-V design, their own chip for controllers in their hard drives.
Oh, how about that?
Yeah, and you can buy developer boards. You can get little boards and stuff now already on this architecture, but that can also be scaled up. So it can be scaled up to the level of those old Unix vendor heavyweight high performance processors on this open design. So and that removes the licensing restriction. It kind of opens things up, but it still has a guiding reference for design.
Mhm.
So that it doesn't just turn into chaos like it did with the Unix vendors. That was chaos.
Sure.
Nothing was compatible. Okay. It was all about vendor lock-in back in those days. That's why they bid it. But so that's an interesting alternative. But yeah, ARM, man, we have not seen the last of ARM. Okay?
Oh, for sure.
And you may have ARM on your desktop sooner than you think. But then again, Intel, AMD, pretty formidable and really, really good stuff.
Sure.
So,
well, I do think with the backing of, I think Apple tends to be kind of a trendsetter in a way, and if they just completely, you know what, we're not going to do x86 anymore, period. And now, because sometimes I feel like it's like the hardware, like who's going to make the jump? The software has got to follow the hardware, and if they want to make software for Apple, then you're going to probably end up doing it for other platforms too.
Yeah. I mean and Apple's in the perfect position to do that. They've done this before. Apple used to be on IBM.
Right.
Design. It was on PowerPC. And then they retooled, and they were on MIPS before that. Mm-hmm. But they retooled, or at least Next was. They retooled for x86 pretty much transparently.
Yeah.
Okay.
I feel like they're
making that change over to the hardware, and they can do that because they have it's a walled garden. They have the hardware and the software. They control the whole shebang, so they can roll that stuff over. And then for developers, they can make that fairly seamless. Just keeps right on rolling.
A few years back, when I was
and they did it.
Yeah, when I was getting into iOS programming for mobile devices, I kind of thought I saw the writing on the wall where Apple was trying to merge their desktop and mobile operating systems. And with this jump to ARM hardware, there's really nothing stopping them now. iOS will be Mac OS, and Mac OS will be iOS. You'll have the same the same exact app on your desktop that you do on your phone or tablet, and it'll be a completely seamless experience across all of their devices. It's only a matter of time now.
Yeah, and it'll take off. I mean, it's already, Amazon has designed their own ARM chips up on AWS. They're some cloud servers. It's more power efficient for a lot of applications. So that so yeah, ARM is just going to keep right on rolling. It's like always, man. I've got a lot of gray hairs. This industry has been so fascinating, so interesting, and so dynamic for so long, and it is not slowing down.
It's good stuff.
Not slowing down. So it's just going to be continuously interesting.
Yeah. All right, we should wrap it up. We're 10, 11 minutes over.
We went over even long for it.
Yeah, that's all right. So I'll say thank you very much, Don, for joining us today. It's always a blast talking with you.
Really fun. I love it.
So and thank you as well to the audience. Just in case, Don, is there anything else you'd like to mention or shout out or?
Just that expect to see some blog posts, some stuff that I'm writing up about using Intel's ecosystem, about using one API. I was going to talk a lot more about that today, but maybe the next time I come up, I'll have some more concrete stuff and maybe doing some demos and stuff like that.
If you're not already, follow Don on Twitter at DB Kinghorn on Twitter. I post the screen name there in the chat.
I don't post very often, but I do. I post on Twitter when I post. When I write something, okay, you can at least count on that.
So yeah, we'll say goodbye. Thank you as well to the audience for joining us today. We do this every Wednesday and Friday at 1 p.m. Pacific. Wednesdays, we bring industry experts from outside the company on to talk about their process workflow, tips, tricks, things like that. And on Fridays, like today, we bring in our member of our labs team, like Don here, to talk about their particular expertise and the crossover with the hardware, software, and things like that. So mark your calendars, Wednesdays, Fridays, 1 p.m. Pacific, and we'll see y'all next time. Bye. Oh, and one last question. Dipanshu, yes, StreamYard is free to an extent. There's options that spread it out if you want to pay. But all right. Okay, bye.